Good afternoon. Thanks for inviting me. My name is Dr. Marcos de la Cruz Marcel Bryan, and it is a great pleasure and honor to be here. Today, I will be talking about the mutational analysis of BRCA1 and BRCA2 genes in Peruvian families with hereditary breast and ovarian cancer. Introduction: Breast cancer is a common issue for women worldwide, including in Peru. BRCA1 and BRCA2 gene mutations significantly increase the risk of breast and ovarian cancer, affecting high-risk families. These mutations vary in frequency and nature among different populations. Recent genetic analysis techniques have uncovered large genomic changes in these genes, particularly in BRCA1. Understanding the genetics of breast cancer has a vitally health implication, offering options for risk reduction. Certain causal mutations are more common in specific ethnic groups, like Ashkenazi Jews and African Americans. This study aims to determine if the prevalence of BRCA1 and BRCA2 mutation in Peruvian patients follows patterns seen in other Hispanic populations and whether unique mutation specific to South America exists. Subjects: Blood samples were taken from 28 patients in 20 high-risk hereditary breast cancer families and the OncoSalud Auna clinic in Peru. They were referred for genetic analysis at the Universidad de San Martín de Porres to assess families' pedigrees and cancer history. Selection of these families followed NCCN criteria for hereditary breast and ovarian cancer. We have genomic DNA insulation and amplification, produced for insulation amplifying genomic DNA from peripheral blood cells basically. This DNA was quantified and 66 pairs of primers were used to amplify specific regions of the BRCA1 and BRCA2 genes. Second, we have RNA extraction and RT-PCR. This study involved RNA extraction, basically for examining the BRCA1 gene and verify blood leukocytes from patients and controls. Total hernia was extracted using artisanal reagents quantified with a cubital fluorometer and reverse transcript with a quantified text reverse transcription kit. Third, quantitative real-time PCR. The use of quantitative real-time PCR to confirm an increase in the copy number of BRCA1 exon 7 after an initial MLP screen. This enabled design primaries for Q-PCR analysis using calibration curves with control DNA. Finally, DNA sequencing, basically for obtained by purifying PCR application and using by-dye terminator, a sequencing kit, and the Avis Prince 3500 genetic analyzer. Mutations were identified by comparing sequentially to the National Center for Biotechnology Information Database. Continue, we have a multiplex ligation-dependent promulgation. The use of MLPA to detect change in the number of BRCA1 and BRCA2 genes copies. The techniques involves DNA determination, probe means hybridization, ligation and fragment amplification. Capillary electrophoresis and coffee laser software are used to data analysis, allowing the quantification of gene copies in each fragment. Second, we have a population-based study by high resolution methods. Firstly, to assess the frequency of novel variants in the BRCA1 and BRCA2 genes in a control group of 100 individuals. So it was used to analysis applications containing these variants, and genotype was done with confidence using melting curve analysis. The study also confirmed that PCR products integrate through algorithms called electrophoresis. Finally, we have a bioinformatics prediction of variants. The use of bioinformatics tools, including phylofen2, SIF, oligonucleotide, and SFINDER, to predict the functional impact of variants of uncertain significance by analyzing residue substitutions on molecules, proteins, and assessing their potential influence on its own splicing and the genes. Now, in this table, we have a pathogenic mutations. In this case, BRCA1 and BRCA2 genes were found in 4 families, representing 22% of cases. A specific mutation include a splice site change is a gene, a 10 base duplication is another, unknown for Ashkenazi Jewish, right, founder mutation. And finally, a novel mutation is another. These mutations were associated with various cancer risks, especially breast cancer, within the affected families. In this family tree of pathogenic mutation, we had the patient's mother and two aunts had breast cancer. One aunt and one granduncle had stomach cancer. One aunt had ovarian cancer, and one uncle had lung cancer. Her paternal half-sister had bilateral breast cancer at age 34. Her father and grandfather had prostate cancer, and a second-degree relative had breast cancer at age 50. Gene dosage alteration. In a study of 18 families, two patients were identified with amplification in exon 7 of the BRCA1 gene through MLPH screening. One patient was diagnosed with breast cancer at age 14, and her sister had also been diagnosed with breast cancer. In another family, an unrelated patient with bilateral breast cancer under 60 age had a similar exon 7 and BRCA1 rearrangement. Independent assets confirm these rearrangements and quantify PCR further support to present of extra copies of exon 7 BRCA1 in both patients. So in this table, we have a variance of uncertain significance. The Onwanka and BRCA1 variant was found to be potentially pathogenic, while BRCA2 variant appears less likely to be pathogenic. A population-based study confirmed the rarity of both variants in the general population. Additionally, for electronic variants in BRCA1 were identified and subjected to silico analysis for further characterization. So we have finally a discussion, the significance of family cancer history in assessing cancer risk and the need of preventive measures. It highlights BRCA1 and BRCA2 genes mutation as a common causes in inherited breast and ovarian cancer, particularly in certain populations. The study discussed the lack of research of these mutations in Peruvian population and present the study of 18 families with hereditary breast and ovarian cancer using genetic sequences and screening to better understand the prevalence and the diversity of BRCA1 mutation in this population. Polymorphisms. The identification of 28 polymorphism variants in BRCA1 and BRCA2 genes previously documented in David NZP and human institute databases. These variants include silent mutation, intronic variants, and misses variants, the one of the five Luchier regions. In pathogenic mutations, because it highlights a mutation, in this case letter H, for C302, which leads to its own exclusion in BRCA1, causing a pathogenic effect in the family with the various cancer types. B. Another family had a novel mutation, for example C4647, and another more, leading to the loss of a critical protein domain. For the letter C, the CA1 and 5, or more, mutation in BRCA1 is prevalent in African Americans. So, another D. Additionally, a well-known mutation, C5946DLT, in BRCA2 was found in Ashkenazi Jewish family. The text raises concerns about the utility of a Hispanic panel for diverse Hispanic population. After have a variance on uncertain significance. In BRCA1 and BRCA2 genes overly, uh, which account for around 50% of the TET variants, it focuses on two specific mutations, C47F in BRCA1 and R155K in BRCA2, while in the first has an unknown significance but shows potential functional alteration, and the second is a novel mutation with contradictory predictions. Basically. Finally, this report is relevant for the local population and justifies the development of the other studies with a large cohort to determine the spectrum and prevalence of BRCA1 and BRCA2 mutation, and possibly founder mutation in the Peruvian population. Finally, thanks for your attention.